Here we're going to look at how to maximize a monopolist profit. This will be a standard calculus-based example. A monopolist has the following market demand. Q equals 14 minus 0.5p. The total cost of production for this firm is given by the following equation. We want to solve for the profit maximizing price, quantity, total revenue, total cost, and level of profit. Step 1, solve the demand equation for P, and that'll give us the inverse demand. So here is our demand equation. We're going to solve that for P. I'm going to add 0.5p to both sides. So adding 0.5p to both sides, we get the following. Now subtracting Q from both sides. And now dividing everything through by 0.5. 14 divided by 0.5 is 28. And minus 1 divided by 0.5 is minus 2. So that is our inverse demand. So that completes the first step. Step 2 is form the profit equation. Profit is total revenue minus total cost, where total revenue is price times quantity. So for price, we're going to plug in that inverse demand, the 28 minus 2Q that we just solved for in step 1. So in step 1, once again, we found that P equals 28 minus 2Q. So I'm substituting that in right here, and that's going to be all multiplied by Q. The next step is we're going to just subtract out total costs. So we had that total cost equation. So we're going to subtract out total cost. And now let's simplify this profit equation. 28 times Q is 28Q, minus 2Q times Q is minus 2Q squared. And then I'm going to distribute this minus sign through the parentheses here, and we get the following. Step 3 is we're going to take the derivative of the profit equation with respect to Q, and we'll set that derivative result equal to 0. The derivative of 28Q is just 28. The derivative of minus 2Q squared, 2 times 2, the exponent times the 2 in front is where the 4 is coming from. And then we subtract 1 from that exponent, leaving us with Q raised to the power of 1, or just Q. The derivative of minus 2 is 0, so don't have to show that. And the derivative of minus 2.5Q is just minus 2.5. And lastly, the derivative of this last term is going to be 2 times 0.125. That's where this 0.25 is coming from. And then once again, subtracting 1 from that exponent, we're just left with Q. That derivative is set equal to 0. Moving on to step 4. We're going to solve the derivative for Q. So here's our derivative result. We're going to solve that for Q. So 28 minus 2.5 is 25.5. Minus 4Q minus 0.25Q is minus 4.25Q. Moving some things around and dividing through by 4.25, the profit maximizing quantity is 6 units of output. Step 5, we're going to get the profit maximizing price, so we're going to take this Q equals 6, and we're going to plug it into the inverse demand equation that we found in step 1. So in step 1, we found P equals 28 minus 2Q. Where we have Q, we're going to replace that with 6, and we get a profit maximizing price here of $16. Step 6, we're going to calculate total revenue and total cost. Total revenue is just price times quantity, so 16 times 6. Total revenue here is $96. And total cost, we're just going to plug in Q equals 6 into our total cost equation. And simplifying that, we get $21.50. So in our final step, we're going to calculate the firm's profit by taking total revenue, minusing out the total cost, and we get $74.50. Okay, that's it.